right, we're in 2-4 today, starting on page 83. I would say this is about the pinnacle of what we're going to learn in terms of linears. This is stuff you learned in Algebra 1. We're going to get back into it today. We're going to write linear equations, so you should be able to take any point off of a graph, and if you're given the slope, we're going to write that equation in slope-intercept form. All right, we might be able to take 2 points off a graph and write an equation in slope-intercept form. You can get from slope-intercept form to standard form, which we talked about earlier on in this chapter. We should be able to talk about parallel and perpendicular lines and how that goes. So right here on page 83, it kind of introduces you to slope-intercept form, or reintroduces you. You have seen this before in Algebra 1. All right, the m is the number in front of the x, or it's the coefficient with x. That makes up our slope. The b is the y-intercept, or where the graph crosses the y-axis. And that is something that you can be positive or negative, both those values. So positive slope has a line that's going to go up as you go from left to right. Negative slope is going to go down from left to right. And then there's times that we can have zero slope, or we can have undefined slope, and we'll be dealing with that more in chapter 2. All right, so we're just going to jump to example 1. So we're y equals mx plus b. All right, let me get it where you can see it a little bit better. Again, this is page 84 in the book. If you can't see it on the screen, then use your ebook or get a class text. So here's what it has. It says in example 1 that we are supposed to write an equation in slope-intercept form for this line. All right, and so this line right here, they give us that we have the point -4, -1, and 0, -2. Remember, if they don't give you the points, then you're just going to look where the graph intersects the grid. So 2 points on the line are -4, -1, and 0, -2. Now, we dealt with slope formula the other day, so let's make sure that we know how to do this again. So I'm going to find, and the slope formula is y2 minus y1 over x2 minus x1. All right? Don't have to memorize it. You can use your notes on test, etc. So if you want to go label these, we can call this first point x1, y1, and this second point x2, y2. It does not matter which one of those you call x1 or y1 and x2 or y2. Just be consistent and make sure you're not calling something x1 and y2. Keep stuff paired together in those ordered pair the way they should be. All right, here we go. So y2 is -2. The formula says minus. y1 is -1. We'll deal with the minus and negative again in a second. We've already looked at that in this chapter, but we'll get a little review in. The denominator says to take x2, which is 0, minus x1, which is -4. All right, clean it up. Remember, we're doing the math in the numerator and in the denominator. Thinking about PEMDAS here, the numerator and the denominator are like doing math with parentheses. That's how we group it together. All right, here we go. -2 minus -1 becomes a big old plus sign right there. So -2 plus 1 is -1. The denominator, 0 minus -4. I make that minus a negative a big plus sign. 0 plus 4 is 4. So our slope is -1/4. Now, you should have expected the slope to be negative. Look what our line's doing. From left to right, that line is going down. So we expected negative slope. In this instance, we know what the y-intercept is. We learned earlier on in this chapter when we were doing standard form that if I have a y-intercept, my x-coordinate would be 0. So it tells me the y-intercept is -2. So for slope-intercept form, we found our slope, which was -1/4. We know that the y-intercept is -2 because of this coordinate point. The x is 0, so my y-intercept is -2. Now let's go write the equation. Here it is. Y equals -1/4 x minus 2. There is the slope-intercept form equation of this line in example 1. So they might give you the slope, or they might give you 2 points, and you've got to be able to find slope-intercept form. Look down here at Guided Practice 1A. They go ahead and give you what m is. It's 4/3. They give you what the y-intercept is because of the point 0, 4. There's our x of 0, so 4 has to be our y-intercept. We wouldn't have to do any math, and we know the equation for 1A would be y equals 4/3 x plus 4. Now, if you were doing 1B, this would be like this example. You would need to go find the slope, but here's your y-intercept right here, 0, -6. So you know the b of y equals mx plus b is -6, and we could write it. Okay, another form you might see is this next one. It's called point slope. So up here, we did slope-intercept. All right, and down here, we're going to look at point slope. To be quite honest with you, I am more of a slope-intercept guy, or maybe standard form, but if the directions ask for point slope, then you need to know how to do it. It's pretty simple. So here's the formula. It's y minus y1 equals m times x minus x1, and what we're looking for is an ordered pair to plug in and then a slope to plug in. This y and this x are the same for us as the y and the x in slope-intercept form. So that's just part of the equation or the function. Let's jump down here at the bottom of page 84 to example 2. And it says write an equation of a line, and the line goes through the point 6, -2, and they tell us the slope is -4. All right? So they say write the equation of this line. They're talking about in slope-intercept form. Well, we can use point slope form to get there. All right? I'm going to show you kind of 2 ways to do this. This is the first way, called point slope form. So I'm going to call this, for my problem, the point they gave us is x1 and y1. So that's similar to setting up slope formula, but we don't have 2 ordered pair here. If we had 2 ordered pair, we could go find the slope, but they already gave us the slope. All right, so let's go plug it in. So the formula says y minus y1. Well, y1 is -2, so you can see I've got minus a negative right there. No big deal. We'll deal with that in a second. Equals m. All right, m is -4 times x minus x1, and x1 is 6. So we've got that going on. So I'm going to clean it up a little bit. I'm going to clean up this side. Minus a negative becomes a big plus sign. So I've got y plus 2 equals -4 times x minus 6. Now, if it said leave your answer in point slope form, we would be done. But you can tell by the notes, we're not done. We got to get y by itself. So to get y by itself, or to get it in slope-intercept form, I need to distribute over here first. I need to multiply before I deal with this -2. Like, well, we're solving for a variable. We do PEMDAS backwards. Yes, that would be correct, but you have to put the problem together first by using PEMDAS. So we got to deal with this side. Here we go. -4 gets distributed. So I'm right here. Y plus 2 equals -4 times x is -4x. -4 times -6 is +24. Now we have it all cleaned up. Now to get y by itself, that's the PEMDAS backwards. All I need to do is move this addition. So we subtract. Now be careful here. Remember, I'm subtracting 2 from the constant. I'm not doing anything with the x because it's not the same last name. Those cancel out, and I get y equals -4x plus 22. Y-intercept of 22, slope of -4. So your slope's going down. Y-intercept's pretty high. It's no big deal. Someone can do it. All right, I want to show you another way. Using the same instructions, I'm going to do guided practice 2A, but I'm going to show you how to do the same thing using slope-intercept form, and I'm going to leave it up to you which way you want to do it. You can either use point slope or you can use slope-intercept, and that's when given a point and the slope. All right, so here we go. I'm at guided practice 2A. So this one says our line passes through the point 2, 3, and that our slope is 1/2. What I like to do is I like to do it a little bit differently. It's just personal preference. I like to start with slope-intercept form, since that's where we're ending up. So here's what they've done. In this equation, they've given us an x, they've given us a y, and they've given us an m. Well, if I go plug in an x, a y, and an m, then all I'm solving for, or what I need to solve for, is b. Well, algebraically, we can solve for one variable. You do it all the time. So it shouldn't be too hard, so let's plug in. So the coordinate they gave us, y is 3, my slope was 1/2, my x is 2, and we're solving for b. All right? Now just do this math. 1/2 times 2 is 1. If you're not good at that, just multiply in the calculator. So we're right here. 3 equals 1 plus b. Now I know b is on the right, and that's fine. So I need to move this +1. How do I do that? I subtract 1 from both sides, and we get b equals 2. Now for y equals mx plus b, there's my slope. Here's my y-intercept down here. Now we can go write the equation. This equation would be y equals 1/2 x plus 2. Slope of 1/2, y-intercept of 2. So there's another way to do it. Point slope form, and slope-intercept form can be used when given a point and the slope. Now, if they give you 2 points, you need to use those 2 points to find the slope and then pick one ordered pair to plug into either one of these. I don't care which way you do it. I'll leave that up to you. So what I was just talking about, we're going to jump to page 85 and try. So page 85, example 3. So it says, write the equation of a line passing through each pair of points. And here's the points, -2, 7, 3, -3. So we got to find the slope first. So I'm ending this problem in y equals mx plus b. I mean, yeah, I know an x and a y, but if I plug those in, I don't know the slope and I don't know the y-intercept, so that doesn't do me any good right now. So here we go. Slope formula says y2 minus y1 over x2 minus x1. Delta y over delta x, or change in y over change in x. Let's go label our ordered pair. There's x1, there's y1, there's x2, there's y2. All right, plug them in. y2 is -3. The formula says minus y1 is 7. Divided by x2 is 3 minus x1 is -2. There's minus a negative. Do the math. -3 minus 7 is -10. If you're not good with your negatives, please use the calculator. All right? Divided by 3 plus 2. We had minus a negative, so it becomes a big plus sign. 3 plus 2 is 5. We have a slope of -2. So there's m is -2. At this point, we have the slope. We have 2 points. I only need 1. So I can either use point-slope form or I can use slope-intercept form. I like slope-intercept form better. Let's go. So that's, again, y equals mx plus b. Let's plug in what we know and solve for what we don't. It does not matter which ordered pair that you use. I'm just going to use the first one. Our y was 7. Our slope is -2. Our x is -2 plus b. Everybody catching that? Again, I plugged in my y. I plugged in my slope. I plugged in my x. And we're solving for b. So 7 equals -2 times -2 is 4 plus b minus 4 on both sides. And I get that b equals 3. So my slope is 2. My b is 3. And I can go write my equation now. Y equals -2x plus 3. There's slope-intercept form. Okay? There's slope-intercept form. The book, if you want to see how to do it point-slope form, step 2 right here walks you through. Get the same answer. Look what they got using point-slope form. Y equals -2x plus 3. Okay? I want to show you part B right there. It's kind of a long day today, which is fine. I want to show you part B. I want to show you what happens. So we got this, 4, -7, 4, 6. Let's go find the slope. So, again, slope is y2 minus y1 over x2 minus x1. If you want to label your points, x1, y1, x2, y2, plug them in. y2 is 6 minus -7. -7 being y1. x2 is 4 minus x1 is 4. All right, something happens here. I explained this earlier in chapter 2, but let's look at it. All right, do the top. 6 plus 7 is 13. 4 minus 4 is 0. Dividing by 0 is undefined. Dividing by 0 doesn't really work for us in math, so we call that an undefined slope. When that happens, there's still an equation because this line contains these 2 points, and here's the equation. X equals 4. Look at your x's. Are they the same? Yes. When that happens, that's got to be a vertical line right there at x equals 4. I'm going to show you another one. Jump down here to guided practice 3C. 3C, right here. The points on our line are -3, -1, and 2, -1. Now, if you kind of see a pattern, you see that the y's are the same. We'll deal with that in a second. Let's go find our slope, and I'll show you what happens. So m equals, if you want to label these, there's x1, y1, x2, y2. So my y2 is -1 minus my y1 is -1. My x2 is 2 minus my x1 is -3. So on the top, 2 negatives like that minus a negative makes a positive. -1 plus 1 is 0. On the bottom, 2 minus -3 becomes 2 plus 3, and that's 5. 0 in the numerator is fine. That's just 0. So we would say right here that our slope is 0. There's nothing wrong with that. What that tells us is the equation is whatever the y-coordinates are of our points. So this equation of this line right here would be y equals -1. Note the last two examples. That's a big deal. 0 on the bottom means undefined slope. We have a vertical line at x equals 4. 0 on the top means 0 slope, and I have a horizontal line at y equals whatever the y-coordinates were in this instance, -1. You can graph this in the calculator still. X equals 4. I don't really know how to do it. All right, I'm going to try to jump into these last two. Let me look at this thing right quick. Maybe splitting this up. Okay. I'm going to come back. I'm going to do a separate lesson on parallel and perpendicular lines to make sure that we can catch that, and that'll be a good review for us with our slope-intercept form and all that stuff. Make sure if it's in my notes that it's getting its way into your notes. You can copy down extra examples or anything else that you want to put in there as well. We're going to keep rolling through Chapter 2. Thanks.